All right, so welcome to Help Systems webinar, 5 Myths About Encryption on IBM. We're going to be looking at a couple different thoughts around encryption and some common beliefs and see what happens with it when we break it down into the simplest form and see if those myths are going to be true or not. Encryption itself dates back to 500 BC. We are all familiar with some form of encryption. Even when we were kids, we probably used some sort of encryption when we're talking to our friends. I remember myself, we used to use Pig Latin to try to trick our teachers. Of course, as an adult, we see how silly that was, and it was so easy to break. However, of course, it's been something that a lot of us have been exposed to for a very long time. My name's Sandi Moore. I'll be your host today. I'm a security consultant with Help Systems. I've been working with customers on the IBM for about 16 years now and helping in multiple roles, making sure that I'm able to interact with customers, support level, training level, also giving webinars like this to share information that we have, to educate people about security principles in general, but also at the software level. So really trying to share that information. I really enjoy working with people and sharing this information. So I'm glad that I'm able to be here today with you. Now I am currently in Reno, Nevada, and we've got some beautiful sunny weather. And so if you are some of those folks on the East Coast or Midwest that are experiencing yet more snow, I'm really sorry to hear that. Spring will come eventually, so hang in there. All right. So I'm sure a lot of you have heard of the show MythBusters and may have enjoyed it yourselves on the Discovery Channel. The MythBusters for me is a lot like my childhood. I had a brother who liked to blow things up and catch things on fire, and MythBusters just reminds me of the things that he would do. So cool show. We're going to kind of use that as our general guideline for our myth busting today of our own and determine whether the following myths around encryption for IBM are founded in some basis of truth, or whether they're going to be debunked, or if maybe these myths land somewhere in between. So we'll start that challenge here. So first thing we're going to look at is myth number 1 is the disk encryption being the silver bullet. And the idea around this is that disk encryption is by encrypting the entire disk, this is going to solve all of those encryption problems and meet any regulatory mandates that you may have. So when we break it down, the full disk encryption is allowing you to take advantage of built-in capability within IBM that was starting in version 6 of the operating system to enact encryption across the entire disk unit, meaning that everything placed on the disk is first encrypted by that disk controller and then written out in encrypted form, which is seamless across the entire disk unit. Initial gut feeling here is that it may be the answer to what you might need to do. The benefit is that it's quick. Most IBMs have a crypto processor or coprocessor built in or have controller cards that are handling encryption at that hardware level. It's the fastest way to do encryption and decryption functions, so you're not waiting on anything. And the question here, though, is that if there's any impact when it's implemented. At the hardware level, the impact is actually going to be pretty minimal. Another benefit is that the disk encryption is non-invasive, and that's really something that we have to strongly consider. What is invasive would be changes that we might have to make to an application or database structure in order to accommodate the encrypted form of the data. And that is definitely would be considered invasive. Most shops don't want to do that. No application or database changes, and you don't want those interactions or visibility for the encryption to happen behind the scenes down at the disk controller. So you really don't have to have anything up front that you're making changes to, which would be definitely non-invasive approach. So if we look at it that way, on our initial evaluation, we have a plausible and possible solution to meet that requirement for encryption. And I'm not quite ready to say that it's the silver bullet. But because it's seamless and it can be quickly implemented, it's significant as well as very appealing. But like I said, we don't really want to jump for joy yet and think that we have a solution because we need to dig a little bit deeper. If we use a Windows laptop or Windows Server, for example, like I have sitting here on my desk, you may have multiple disk drives attached to it. And if we look at it in the simplest form, taking out any RAID structures, firewalls, any other protections that might be in place, you basically just have multiple drives on that server that are available. And if you take off the case, pull one of those drives out, you can potentially input it into a secondary server, and then you're most likely going to be able to read the contents of that drive. So, of course, there is the possibility of someone stealing a disk, reallocating it, and reallocation of it may not be done properly, as well as disposing of improperly disposing of that data could expose the data. So multiple levels, having a disk that can be removed, the disk encryption itself is maybe not the best answer. Of course, you can see this Jackson Pollock painting here. I personally am not a big fan of this type of art, but for illustration purposes, you can compare maybe the IBM is more like a Jackson Pollock painting because it is scattering disk data across all the drives in the array, not unlike his paint scattered all over the place, maybe not making sense to some of us. So even without that parity protection, IBM is balancing that data across the units. So the act of simply removing and installing the disk into another system may not work. And the idea that someone is stealing the data incorrectly is they're not able to simply install that drive into another unit. So not apples to apples here, but certainly something to consider. If you are using internal disk drives in the chassis of the server, that full disk encryption has limited benefits. So it does have the speed and is non-invasive. And then you're potentially going to get that check mark on that regulatory compliance mandate. So sometimes that's all people are looking for. But if you're really truly trying to protect the data and you're serious about it, getting that check mark is not going to be the only thing you're after. If you're using an external disk on a local area network, that physical drive unit is in a different location from the disk controller, then doing full disk encryption actually can be beneficial. So it's not a total loss. When you think about it, that encryption is traveling down the wire. So if someone's intercepted that wire, everything that came out was in encrypted form. Likewise, when that data is coming back, the decryption takes place, the data hits the server itself. So the deciding factor on full disk encryption is whether doing internal or external disk. If you already have the capability for encryption, then you want to take advantage of it. Why not? I mean, this is something that's already provided. If it's already there, you think of it similar to a firewall functionality where your system is behind a firewall, so you really don't think about it. If the functionality is there, use it to your advantage. Some of the big inhibitors to why full disk encryption is not going to solve the requirement is that the encryption and decryption is not going to interact with any applications or with the operating system. There's no differentiation between authorized functions or unauthorized functions. No conditions or decisions are being made at that point when the data is requested. The operating doesn't care. It gives that data in clear text access regardless of the interface the user's taking advantage of. And from a security standpoint, I really want to have decisions to be made as if that user can see that data in clear text or not, and how are they accessing it. All right, so myth number one, unfortunately, I think we've busted it. Full disk encryption has some value for sure, but it's not the end-all be-all answer. Now, the average shop is looking for data protection, and this helps with those remote disks, but it's not conditional and doesn't really give us enough protection. All right, myth number 2, encrypt everything. And this is a classic one. I've heard that come from non-IBMI individuals especially, and auditors love to be able to say, hey, just show me that everything's encrypted. And it, is considered an evolution of disk encryption. If everything's encrypted, then by default, maybe the belief is that nothing is at risk. So if we kind of scroll back into history there, a couple things to consider and talk about the Enigma machine. So this machine was basically a series of electromechanical rotor cipher machines that were developed and used in the early to mid 20th century to protect commercial, diplomatic, and military communications. And even though it had some cryptographic weaknesses, in practice, when it was actually implemented and its biggest use during World War II to protect German communications, it wasn't the Enigma machine itself that had the problem. It was the operator errors and the procedural flaws that was its actual downfall. And with that, there was a failure with the German troops to systematically introduce changes in their procedures. And so when the Allies captured the key tables and the hardware, and they were actually able to find a pattern in the data and start to decrypt those communications, and which in turn turned the tide for the Allies as far as the success during World War II. So the tale here is really to encourage you to be cautious of encrypting highly repetitive data as patterns do begin to emerge. And once a pattern is observed, then that encryption is going to break down and has a better chance of being broken. When we're talking about encrypting everything, the other thing you really need to consider is the performance. And we've talked about disk encryption being fast, and it's done at the hardware level, and the faster the hardware is, the faster that disk encryption is going to run. So, but encryption, when you're encrypting everything, is being done at the software level. It's definitely going to have some performance considerations because you're limiting to just if you're limiting to just the sensitive data, that can limit the impact. So the only doing something with data when it's requested is another concern. Having it fully encrypted all the time, that's in its state and not being used is not going to hurt it. But once you need that information, that's going to up the performance issues. If you're trying to encrypt every single field, even non-sensitive data, the idea of taking on that overhead really should be part of the conversation. So often when we first have conversations with companies about encryption, you have to discuss really what should be encrypted. And two parts of that should be looked at. First is deciding what is considered to be sensitive. What's important to you. Sometimes it's dictated by those regulatory mandates, social security numbers, credit card numbers, birth dates, that sort of information. But there could be other data that's valuable to the company, such as trade secrets, formulas. Once you've determined what is sensitive to you, the second agenda item is where is that data and how is it stored? And there may be some data in multiple databases, and your databases may not be normalized. So it may be a bigger task to find it, and it certainly adds to that and can be an argument for some companies for let's just encrypt everything. So the next thing, of course, is to prioritize that data and classify it by the levels of sensitivity, to focus on that data. And this can be overwhelming and is very tempting to lean back towards that full disk encryption. But really, the focus should be on the sensitive data. And when you're looking at it, looking for things that are going to be deemed by those regulatory mandates, very typically PCI data, PII data, PHI data, bank account numbers, user IDs and passwords. We often take our user IDs and passwords for granted that those are protected, but there's ways that those can be exposed. PIN numbers, payroll information. wages, not only just the wages, but someone's bank information if you're doing a direct deposit, a customer's driver's license number, or an employee's. And of course, financial data for the company. That may be something that you don't want to release. We work with a lot of privately held companies that they may not want to have that financial data out there. And of course, trade secrets. One thought there is Kentucky Fried Chicken and their recipe for fried chicken. They're certainly going to guard that. They guard that trade secret very closely, but the recipe for Coca-Cola as well. So many different things, product formulas, even sources for raw materials. You may not want that exposed. People figure out where you get your raw materials. They can figure out maybe how to work backwards from your formula and figure out what you've used and how you've made your product. All right, so I'm going to have to say here that this myth is also busted. And we don't really want to encrypt everything. You don't want to have patterns develop, and you don't want the impact to the environment. And if you're smart about it, it's not impossible to tackle it properly. You just need to know the apps you have on the system, and that's a really great place to start. If you know you have a financial application on the system, you know there's going to be financial data. You know that you have employee information on there. Highly likely you're going to have PII data, maybe even PHI data. Who has health insurance? How many of the people of that employee, how many family members are on health insurance? So information that could be gleaned and should be protected there. Now, I actually have a quick poll here because we're talking about the type of data that might be on your system. I'm going to shoot this poll out here. And let's see, I want to find out if you have actually, as a company, categorized your data. When we talk about what type of data is on your system, have you actually made any progress for that? Have you gone through? Are you fully aware of all of your data? Do you have a general sense of, because you know what your applications are, that there's probably some information in there? Maybe you haven't had a chance to look at it yet, but it's that project that's sitting on the back burner and you're not really ready to tackle it. And then, of course, every once in a while, I run into companies that really don't feel that they have sensitive information on their system and they don't really see a need to protect it. And I find that hard to believe when companies use the IBMI very often is the backbone of the company and most of the business runs off of it. There's valuable information out there. So sometimes you have to really think outside the box and see if, in fact, that particular data is sensitive. If it did get into the wrong hands, would that be a problem? So, all right, I'm going to give you a couple seconds left here. We've got some people still answering that poll. Really, I think when we have that encryption conversation, the type of data and where the data is very often the biggest challenge. So being aware of it now is going to give you that much more head start on tackling that project. All right, I'm going to go ahead and stop our poll here and go back to. All right, so looks like on that poll there, we had 83% of people are fully aware of where their data is. So there's been a lot of work done, and I'm impressed with that. 6% of our respondents here sort of know where the data is, and they might need some help identifying it. And not surprisingly, there are 11% that haven't actually classified or categorized their data yet, but they know that they need to do it. So. But nobody is claiming to not have sensitive data, so I really appreciate the honesty there. It is definitely something that is overlooked, but appreciate that you're not in denial here. All right, let's carry on here with our myth busting. All right, myth number 3, looking at encryption algorithms and considering the fact that maybe those encryption algorithms are not created equal. So the idea here is that encryption as a general topic is something that should come under scrutiny. when we're talking about how that encryption occurs. When we're talking about, and I do this all the time, we're talking about the security commandments in our webinars, presentations, and customer conversations as to the necessity and criticality of implementing good security controls. But if we actually break down those security commandments, two of them are to protect the sensitive data. And if you look at the regulations that are potentially giving you those mandates, they specify that the sensitive data needs to be protected. Okay, great, let's protect it. But secondly, they don't say exactly how to do it, but they make a general reference to using strong encryption. And that definition of strong encryption changes over time. So I really feel that they leave it intentionally vague. And, all of the ciphers that are available, it's based on that computational security. And any cipher eventually can be hacked or cracked. So really, by leaving this vague and only saying that you need to use strong encryption, it leaves room for improvement. So when one particular type of encryption has been compromised, you move to the next strongest encryption method. So, really leaving it vague for most of the time. However, that strong cryptography definition being broad, PCI Security Standards Council actually does define it. So unusual, but in fact they do. And what they are saying specifically there for that PCI Security Standards Council is that the cryptography should be based on industry-tested and accepted algorithms, along with strong key lengths, minimum of 112 bits of effective key strength, as well as proper key management practices. And that cryptography is a method to protect data and includes both encryption, which is reversible, and hashing, which is not reversible, or it's a one-way. So examples of that industry-tested and accepted standards and algorithms for minimum encryption strength include AES, which is 128 bits and higher, TDS, minimum triple strength length keys, RSA, ECC, and EI-GAML bits and higher. So, very specific there. But really, with the strong encryption, any encryption, it's not a set it once and forget it situation. It does evolve over time, and keys that were once considered strong have been broken. So we have to talk about the differences between the algorithms, and that's the idea of a key system. And the first difference between them is that there's two basic systems for the keys, the symmetric and the asymmetric. Symmetric key system is where there's a key that is used for both encryption and decryption function. If you send the data, you've encrypted the data with the key, and you send that data to another person, let's say you're sending it to me, you're going to have to send me the key with it so that I can actually read the data that that you sent to me. So now I have to actually send the key, and that could potentially expose the data. So sometimes you kind of get yourself into a catch-22 there. You have to provide the data, but with the symmetric key, you're going to have to provide that key as well. So maybe, think of it in terms of if it's an internal access and you're giving that data to someone internally, that symmetric key will be all right. But really, when you start talking about sharing that data publicly, there needs to be two keys. And that's where the asymmetric cryptography comes in. And so you'll have the two keys, the public key for the encryption and then a private key to decrypt. You're not going to distribute that key, and so you're not going to have to use one or the other of these key systems. You can actually use both of them. So a symmetric key for the data at rest on the system, and an asymmetric key when you have to share that data outside with someone else. And the decision about which type you're going to use is really going to depend on what you're trying to accomplish. All right, so of course there has to be a conversation about the effectiveness of this cryptographic ecosystem. And the strength of your encryption method is going to be influenced by a number of things. Truly, it comes down to three factors. And the first one is your choice of algorithms. And there's numerous algorithms available, including AES, DES, RSA, triple DES, which are all different types of algorithms and are going to be available for either an asymmetric or symmetric approach. And second factor here is that the length of the key is so critical. Longer is definitely going to be better. The complexity and the number of combinations available, as well as the length, is going to be more resistant to any brute force attack that you might come under. Of course, the pun here is that the key to the encryption is the key itself. So the secrecy of the key is going to be influencing the resistance to abuse of that encrypted data. So really, if you expose your key, you now have undone all the protection you had of that encryption and needing a key to actually decrypt that data and have that data in the clear. Okay, so I'm sure that many of you have seen all the charts and infographics floating around out there talking about how long it can take to brute force hack a key. You're going to see things like this one here. And on the right-hand side of the graphic, you can see how long it would take the 7 billion people on the planet to break a 256-bit encryption key. And so 7 billion people on the planet, every person on the planet owns 10 computers, assuming, probably don't, but on the average, that might be what it breaks down to. And then each computer can run a test of 1 billion combinations per second. With those numbers, it would actually take 77 septillion years. So, yes, I did have to look it up because all those zeros, I really didn't know what to call it. So, I learned something new today. That is septillion years. So, obviously, it would take a really long time. But what I want you to remember is that, yes, the statistics are staggering. And if you use a strong key really hard, and you're not going to be able to break it easily. But the reality is that it would break before someone got through all of those combinations. So think about a PIN number, for example. It would take 9,999 attempts to break it. But if my PIN number was 0003, then you really would only have to go through 3 iterations to break it. And it is definitely going to be easier to break. So kind of breaks it down and makes it a little bit easier to digest. And always take these infographics with a grain of salt. Yes, that longer is better, but really you don't go through every combination before you hit the actual key to it. Okay, so back to our MythBusters. I would say that this one has been confirmed. And although not only are they not all created equal, and some of those encryption algorithms are deemed weak or broken, but there are so many different types of algorithms, and it all comes down to the length and the protection of the key. And while this is outside of the control of the encryption itself, if you don't take care of the key, it doesn't matter how strong that encryption is. The recommendation here is to use industry standard protocols. AES is essentially the standard here in North America. So that's where you're going to see the most. It was selected by the National Institute of Standards of Technology, or NIST, as their recommended algorithm. And so you want to make sure you're using that standard encryption protocol based on sound mathematical knowledge and put associated protections around it. Okay, myth number 4. I like this one. This is that the encryption is a get out of jail free card. So, that myth is that if you do encryption, you're off the hook. If it was the get out of jail free card and you were off the hook and I get breached, I'm not in trouble. And unfortunately, though, it's a vicious rumor when we're talking about those regulatory mandates. Those mandates and the people who set them in place, they're no dummies. And they're not going to be fooled by your excuse that, hey, it was encrypted, I'm okay. When we're talking about those regulatory mandates, they're increasingly calling for encryption for a way to protect the data, and there's ways of obfuscating that sensitive data so that it is, if it is compromised, it cannot be used or is unrecognizable. When we start talking about GDPR, which went into effect almost a year ago now, which is crazy. It seems like it was just coming down the pipe and we were all trying to figure out what it was. But almost a year later, really, GDPR speaks clearly that to the fact that encryption is required, and if there's a breach, encryption alleviates the reporting requirement to the data subject, but you still have to report that breach to the overseeing authority. So it doesn't get you completely off the hook. So I encourage you to carefully evaluate the overall sense and specifics of the regulations that you're trying to meet. And really consider that damaged or unauthorized destruction of data by some standards, including GDPR, would actually be considered a violation. So really have to be careful, not only that the data is protected and encrypted, but that you still have access to it. So, of course, here the thought is to use those strong encryption keys and guard those keys closely. I know I keep going back to that, but I can't emphasize enough that this is so critical. Okay, this was a short one. This one was an easy one to bust. And really, it's a bummer, but you have to consider this busted. Encryption itself is very important, but it isn't the silver bullet. A lot of other controls need to be leveraged in addition to the encryption, and that overall security infrastructure is critical regardless of the sensitive data being encrypted. All right. Myth number 5, last one here that we'll talk about, is that encryption is complicated. And personally, my mind's blown. It certainly can be complicated. And if you go back in history, there's some pretty simple algorithms, but if you start following it a couple years into it, it does very quickly become complicated. And I'm not a math whiz. I'm really good at solving problems, but math really just isn't my forte. So this is where those algorithms really can start to make things more difficult. So when we look at it, the complications of it and the things that have scared people, first thing we look at is the APIs, or the application programming interfaces, introduced at v5.r4 by IBM, and it really did add complication. What it does is it allowed for the encryption and decryption functions. So when you're doing that API programming, though, that API relies on the database structure supporting the format of the data in its encrypted state. So what it produced is some need for pretty invasive changes to the database. Change to the length and character set of the field very definitely would be considered invasive. The other side of it is that it also requires invasive changes to the applications. The API call only happens when the data is accessed, but not unlike the Y2K project, the code had to be added to the applications for that change in the field. So you have to consider the many factors, including the sort as well as the need to recompile those programs. Now, the API calls are only made when needed, which does help with the speed of data availability and certainly could be considered more efficient. So fast and efficient, that's a good thing. You might also need to consider that if you're using alternate methods to download the data, that there's no integration with the operating system to decrypt that data when it's requested. So what I mean by that is if it's a legitimate access to the data, you have to go through extra steps to give the user access to the readable data. It's not going to be automatic. They request the data, they're going to get it encrypted. So an extra step has to be set to actually get the data in a readable form to the user. And while it's a really good solution for application providers because they could write these APIs once and then deploy it many times in different ways, really doesn't work well for people that own their own business or employees of a small business because of the complications. And it really just makes things so much more difficult. So not necessarily usable to the general public, but certainly was a big hurrah for software companies. So just here an example of what that invasive database change would entail. So in this example, you've got a real feel for how invasive it is in order to support that encryption. And the data here, you've got your social security number field, and your length is a 9-numeric field. But when you add the encryption, you go from having data that's 9 characters to now you need a 16 alpha field. So big change. And it's going to require recompiles to the application as well, even if the database file isn't used much in that program. An example here, of course, shows the invasiveness of the application changes. You really have to determine if the user is authorized to see that data in the clear. Then you need to call that decryption routine. Otherwise, you're going to need to mask it. It's not overly complex, but considered extremely invasive because still there's a lot of work to be done around it. Now, the database trigger was added as part of the database structure in v5.r4 as well. It allows us to fire off an event when data is read, changed, or deleted. The idea here is that we can do something at the database level without the application having to be involved. So, not unlike the API approach, you still have to make structural database changes for encryption, but you don't have any invasive changes to your application layer. So, a little bit better. While it's true that the encryption side doesn't require changes to the application, though, in order for the user to decrypt the data, you do have to make some application changes. So the encryption itself is not invasive for your application, but decryption is. And those read triggers have some security restrictions on them when you're modifying the way the data looks. And these restrictions can be very impactful. Of course, again, there's no OS integration, which means that if I were to run a query outside of the application, then I'm just going to get encrypted data. It doesn't help me. And there are authorized, valid reasons for users to collect data outside of those specific applications. And then you also have to consider performance when we're looking at the read trigger. Every time it's called, it involves a program. And if you do a select all column, there's going to be a significant impact in returning that data. On changes and deletes, of course, it's not going to be a big deal, but really on that read, it could definitely be impactful to the user and the performance. Yeah, IBM put out a Red Book publication in 2008, and it really dealt with the complex APIs, the triggers, SQL directives, being the primary options for encrypting that native data at rest. And it was really central to vendors due to that complexity and wasn't really helpful to the average shop and to individuals directly. But soon after this Red Book publication was released, IBM did make some changes. And that was back at v7.r1. When that came along, they added what are called field procedures. So unlike the APIs and triggers, no changes need to be made to the database structure when you're using a field procedure. The field length itself is not impacted, making it more accessible to the average user or shop. It's also not invasive to most applications. Because that data appears the same to the application, it doesn't need any accommodation. So with that field procedure, that file and that field looks the same to your applications. They don't have to know that anything's being handled differently, that encrypted data at the field level, it doesn't matter how the request comes in, which is where that full integration with the operating system functions is so critical. Regardless of how the user is requesting the data, whether I'm going through my application, I'm doing running a SQL statement, I'm pulling it through ODBC into an Excel spreadsheet, that data is going to be presented to the user in the format that was designated for them. In other words, if they're going to be able to see the data in the clear, they will see it regardless of how they requested it. The operating system cooperates with it and gives the correct iteration of the data. And if it's appropriate for it to be decrypted in the full, then that's what it'll give them. Now, the field procedures can be controlled programmatically. And really, this is where the beauty of it comes in, is that you are able to determine, based on need, if that user can see the full data in clear text, if they're going to see partially masked data. Maybe a customer service rep only needs to see the last four of a customer's social security number, or maybe that user has no business seeing any of that data and it's fully masked. So programmatically, you get to decide how it's presented to the user and how it's going to be handled. Now, of course, with any type of interaction like that, there are performance considerations that have to be addressed. Of course, with those fields being decrypted as requested, there can be some overhead added. And so really that's where careful planning comes in, to be able to help balance the performance while still achieving the protection of that sensitive data. Consider only encrypting the truly sensitive data. Back to that whole, if you encrypt everything, it's going to slow things down. So really focus in on those fields that need to be protected and not all the rest of them that are not as critical. All right, so I actually think I've busted this myth. Encryption in theory is certainly very highly complex, but depending on how you actually go about it, implementation of that encryption doesn't have to be that complicated. It is accessible by the average shop. All right, so a couple of things that we have to consider with encryption are, for the savvy individual, is that all of these options require key management. So regardless of how you actually decide to encrypt the data, you're going to have to consider your key management. Those keys, we've hounded on this already, but those keys need to be protected and they need to be managed in a way that they're not going to be exposed, but they're still available to the correct individuals. And they need to be available for that decryption when that decryption is requested, but they need to have that complexity to get the job done to keep that data from being hacked. And of course, with any of the database level options, you also have to consider what happens with the sorting and searching. Because that data is now stored in its encrypted state, the readable data is not going to be readily sorted on. And when you're doing a sort, you may have to use an SQL statement with an order by, but you really want to use caution when doing so, because the number of records that you run over that may actually impact how long it takes. And of course, really want you to think about is if you would have to question why someone is searching or sorting on a field that holds that sensitive data. Very unusual to do a search on a credit card number or do a search on a social security number or a date of birth. Some of those are possibilities, but it's really highly unlikely or that it would be appropriate. But, there's going to be a use case for it. Just really a consideration that needs to be thrown out there. Some folks have also asked us about RowColumn access control as a solution for protecting that sensitive data. But really what you need to keep in mind is that RowColumn access control secures the data, but it does not encrypt it. So it's not going to help you meet that mandate that the data is encrypted. It secures it when it's being accessed, but it's sitting there at rest. It is not encrypted. So if someone is getting around those access points, then they may have the ability to see the information. And there's a lot of ways you can secure data, but when encryption is required, the RowColumn access control just isn't going to meet that mandate. So encryption is no excuse for poor security practices. And, really, we see here time and time again that shops rely on one aspect of security for a total security solution, and you just can't do that. Encrypting data is not going to get you off the hook from poor security practices. Really, making sure that authorized users accessing data are monitored, and it's controlled how they get to the data and what they're doing with it when they get to it. You can't leave the system wide open. Even though the data is encrypted, if you have a bad security practice and users are able to delete the data, it doesn't matter if it's encrypted. If it's clobbered, it's gone. So really, there has to be layers of security in place, and that encryption is not going to be that one thing that makes your system secure. All right, one more poll here before we get down to the nitty gritty on what else. Really want to ask everybody here. I figure that if you have joined our webinar today, that you probably fall under some sort of compliance mandate. So really want to get a feel for how many of you actually do have compliance mandates you have to meet. Maybe if you have regular audits and are experts at this, or if maybe you do fall under the mandates, but IBMI, man, sometimes you can fly under the radar. Auditors don't pay a whole lot of attention to you, and that of course is double-edged sword there. If auditors aren't watching, then maybe you're not looking for more solutions, and it could leave that data exposed. And when it comes down to it, you may still be held responsible. Even though the auditor didn't question it, they might be able to nail you on it. Or maybe if you're still trying to figure out GDPR and other mandates that might be affecting your company, I think for the most part it's pretty clear as to public or privately held. But really with GDPR, companies don't realize that if you do business in any way, like on your website with someone that falls under GDPR, if they're in your European Union, you actually may need to meet those GDPR requirements. Even though you may not directly think you're involved with EU, even your website can be impacted. So, and then of course, you might be lucky and not have any compliance mandate. All right, so looks like we've got some results coming in here. It's pretty mixed. So we do have a couple folks here. 40% do have regular audits. I'm sorry. 25% don't have the auditors bothering them much. So that's actually okay. Just as long as you're doing your due diligence, even if the auditor doesn't ask, you still need to make sure that you're meeting those requirements. Nobody says they're still trying to figure out if they fall under those mandates. So kudos if you're that well versed. And then we've got about a third of individuals voting here that actually don't have any compliance mandates. So I'm happy you're here, because that does mean that you are interested in protecting the data, even though no one's forcing you to protect it. So kudos there. All right, I'm going to give you just another second here, and then I'm going to close out that poll if you want to grab that real quick. All right. All right, let's get back to our conversation about encryption. So something that we have that we can help you with is PowerTech Encryption for IBMI. And what we've got is gives you multiple facets of encryption. And it's actually kind of exciting. I love working with this software, so I'm excited I get to share it with you today. We're going to provide with our encryption for IBM native encryption for that DB2 data at rest, encryption for IFS stream files. You know, a lot of people don't think about having IFS stream files out there, and is it going to be impacted? Think about it this way. If you print data to a spooled file that has sensitive information in it and you had the authority to read it, it's in that spooled file somebody could look at. So maybe you need to encrypt that, as well as backup media. So being able to do encrypted backups. So just a little idea here for you to give you a sense of what it's going to do is with using those field procedures and doing the encryption over that DB2 file and that data at rest, when a user inserts new data to the system, they're going to have that data. As soon as they press enter, with those field procedures, you're going to be able to encrypt automatically that data. And when a user goes back to read that data that's been added to that DB2 file, you're going to be able to programmatically decide. We mentioned before how the user is going to be able to read it. If they're going to get the unmasked data and get everything, the partially masked data. So that customer service rep that only needs to see the last 4, or maybe that automatic email that generates to a customer after they order that says, hey, you've just ordered payment method, and it shows the last 4 of the credit card number. That's where that partial masking is going to give you that benefit. And then the fully masked data, making sure that users that are not authorized to read that sensitive data, they get to see the masked information. They don't get the data. They don't have the access to it. So really automated through the background, doesn't matter how they request the information. Because it's using the field procedures at the field level, fully integrated with the operating system, when that user requests the information, we refer to those authorization lists, and we know how we should show the user that information. So thorough encryption and protection of that data. Backup encryption available as well. So recommendations to minimize your backup window would be to only encrypt libraries or objects which contain sensitive data. Again, going back to focusing on what's important, not trying to do everything. If you have enough disk space, consider saving to save files first, and then back up those save files using the encrypted save file command. For disaster recovery, you would restore that PowerTech Encryption for IBM library in order to utilize the decrypt commands. And then, of course, you've got an automatic 30-day trial on that disaster recovery box. So that data, it was protected. It was still encrypted and protected. You restored onto that disaster recovery system, and you're able to bring that data back up. But you know that while it was waiting for you to need it, it was encrypted. You can integrate it into BRMS. It supports key-based as well as password-based protection. So really a full solution there for ensuring that your backups are protected and they are encrypted, meeting those requirements again. All right, IFS encryption. Being able to encrypt anything that's stored in an IFS directory. So you can automatically encrypt all of the documents that are added into those selected directories. So regardless of what type of file's in there, it's encrypted. When an authorized user accesses that directory, it's automatically going to decrypt it and allow the user to see it. And it gives you the flexibility and the benefit of being able to encrypt PDF documents that are stored from any of your document management solutions. For example, our help systems web docs. So easy protection over those files once they're in that printed format. And of course, cannot have a conversation about any encryption product without talking about the key management, because of course, protecting the keys is so critical. With our PowerTech Encryption for IBM, there's no external key manager required. So you're able to establish an overall policy of how those keys are created and utilized, assign who can create and manage keys for separation of duties, provide key rotation, all of those controls that are necessary to meet those mandates and protect them, and making sure that you have that data stored appropriately. The keys are randomly generated. And then, of course, controls over which users are going to be able to encrypt and decrypt data, which keys are allowed to use for encryption and which are used for decryption. So full key management to make sure that you are doing it correctly. So quick couple of print screens here. I know we're running up close to the top of the hour. Just want to show you there. Field encryption off of that menu. Very simple process in being able to set it up. Working with field encryption. Again, easy to do. And then adding your database field to the registry to say that, hey, this is the field that is sensitive. I need to encrypt it. So really just giving you easy, simple access. You can even prompt it when you're adding that field to validate that you in fact did pick the correct field name, file name, and library, and that you've got the field information correct as well. Easy to use. When you activate it, that data is now encrypted, and it's going to honor which user has access to the data and how. Masked, fully masked, or partially masked. Authorization lists are used to determine which user gets to see which value. So really being able to easily take advantage of parts of the operating system already there. Authorization lists have existed since the beginning. So being able to use that to your advantage, you may already have authorization lists in place built around your applications, so easy integration. And of course, your field masking, the flexibility to determine how users are able to see the data and how many characters to show. This one, for example, that credit card number, it's going to show 2 characters on the left and 4 on the right. And then everything in between is going to have a hashtag. And if the user's not authorized at all, they're going to see the asterisk. So really being able to change that up to fit what you want it to look like gives you the control and the flexibility to have it look exactly the way you want. Here's an example of that application data in a protected view. Credit card number, this user was not authorized at all. They had the fully masked value. They get all asterisks. So no data that's sensitive is being exposed. And of course, if it's the non-protected view, that's what the user would see. So easy to determine how it's going to happen. And then, of course, the partially masked. Important there. They can see those last 4 and the first 2, then maybe on Social Security number, the last 4. So ensuring that regardless of what the need is there, you're able to make it look how it's supposed to for that user. Of course, no matter how the user gets at the data, because it's using the field procedures, you are controlling regardless of that request, whether they're using a SQL, if they're using Query 400, that masked view is honored. All right. Any of those tools still going to honor that. All right. So PowerTech Encryption for IBM free 30-day trial is available for download. Uses minimal disk space. Most customers can install and start encrypting that data in really less than a couple of hours. The manual itself is very comprehensive and easy to read. We've got online help text, and you can evaluate that test data in your own environment. So really being able to run it through its paces, see if it's going to work for you, and see the visible results, the tangible results right out of the gate. So, all right. Another thing to consider there, and we'll wrap this up, is our free security scan. So if you're looking at getting a high-level overview of the state of security on your IBM I highly encourage you to participate in our security scan. Set it up. We'll do an hour review with you. It'll give you information that's easy to read, easy to digest, and share with management and when you're doing your planning to see which projects need to come first, what's our priority, and then figure out how you're going to tackle it. Okay, I already gave those polls, so unfortunately, we did run up to the very top of the hour. Long-winded today, so really appreciate you hanging in there with me and participating for the full webinar. If you have any questions, please feel free to email me. I'll be happy to answer those for you. If you want to shoot through some questions, I will reply to those offline. Really appreciate you sitting here and taking the time to learn some more about encryption, and hopefully you got some takeaways from it, and appreciate the fact that there's a lot of myths about surrounding encryption, and when you break it down, really it's a fairly straightforward process. All right. Have a lovely day. Hope to see you again at our next webinar.